All right, so we are starting algebraic expressions with writing proofs. So it's the same thing you did in Algebra 1 where you solved an algebra equation, except now you're going to write your reason why you're doing something. And your reasons are going to be one of these properties. So you already know how to do these properties. They're just going to look a little bit different because they're going to be used with variables. Okay, so for example, the addition property. It looks like this. And every one of these are written in if-then form. So they're all going to be conditional. So if A equals B. So if A equals B, then the addition property says I can add something to both sides and it is still equal. So if A equals B, then A plus C is equal to B plus C. Subtraction property works exactly the same way. If you subtract 3 from the left, you subtract 3 from the right, the equation still is equal, okay? So if A equals B, then A minus C equals B minus C. And you can probably guess that multiplication and division works the same way. So if A equals B, that's a terrible looking A, then A times C is equal to B times C. So that would be multiplying both sides by the same number. And then, of course, you know when you're solving an equation and it says like 2x equals 4, then you divide both sides by 2. That's because the division property says that works. So if A equals B, then A divided by C is equal to B divided by C. All right, distributive property, again, you already know how to do it. If I give you A times B plus C, then you know that A times B plus C is equal to AB plus AC, because you have to distribute that A to both sides, or to both parts of the parentheses, sorry. Substitution. So if A equals B, then A may be replaced by B in any expression or equation. So for example, if you go out to dinner and you order a Coke and they say, I'm sorry, we don't have Coke, we have Pepsi. What do? You substitute Pepsi for the soda that you wanted. You just replace it. Or water or tea or whatever. You're still not getting what you ordered, you're replacing it with something else, okay? Reflexive property may be new. Reflexive is like looking in a mirror. When you look in a mirror, you see yourself, correct? Well, for anything, any real number, anything at all, A is equal to itself. Which, 3 equals 3, 10 equals 10, okay? Symmetric. Symmetric is just when two things trade places. So if A is equal to B, then B is also equal to A. That's why when you're solving an equation and you get something and you're like, blah, 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 and then it says 4 equals X. So what's the answer? You know X is 4 because symmetric property says it's okay to switch them back and forth, okay? Transitive property, this one's pretty popular. So if A equals B and B is equal to C, then what do we know for a fact? We know that A is equal to C. So if X is equal to 4 and 4 is equal to Y, so think about if X is equal to 4 and 4 is equal to Y, then what do we know? That X is equal to Y. Exactly. So here we go. So using the properties of equality. So what we're going to do is we're going to write what's called a two-column proof. Two-column proof because it's like a T-chart. You have statements on the left. So these are your statements on the left. And you're going to have reasons on the right. So basically, you're going to make a statement. I'm going to say why, and you're going to give me a reason. Okay? So what can be used for reasons? Well, reasons can be definitions. They can be properties like the ones we just did. They can be postulates and theorems. Like Pythagorean theorem would be a very good reason why you did something with a right triangle. So when you are writing a proof, the first ones we're going to do are going to start out very simple, where I give you the statements and you have to come up with the reason why. And then it's going to progress to you have to come up with your own statements and your own reasons. Okay? When you are writing a proof, you will always be given some information. They'll tell you, I'm giving you this piece of information and I want you to prove this. This will always be your very last step. You cannot use it anywhere else in the proof. If you try to use this part anywhere else in the proof, your proof is automatically wrong. Okay? It has to be last. This will always be your very first step, because you can't write something until you're given something to start with. And the reason that you're writing it down is because that's what is given. The word prove will never be used in the proof. You can't say, oh, here it is, I'm going to write prove because I wrote given next to this. That is not how it works. You will not write this word. Okay? That word is a direction. That is where I want you to end up. It is not part of your proof. Okay? Every year, it always fails. Somebody's like, oh, I'll just write these 4 pieces in my proof and keep going. That's not how it works. Okay? So what you do is you take what's given, you write it down, and you tell me, hey, I wrote this down because this is what you gave me. And then you start solving. So from step 1 to step 2, I see that the 4x matches. I see my equal signs match. But I see that this -1 moved to the other side. So I used the addition property because I added 1 to both sides. So I'm just going to write here, add 1. All right, so since we added 1 to both sides, then to go from step 2 to step 3, I noticed that I have to divide by 4. So this would be the division property. So I'm going to put divide by 4 in parentheses just for myself so I know what I did, because these are my notes. And I'm going to want to refer to my notes when I start on the actual assignment. So if I don't understand why something happened, I have the notes to help me figure out what happened. All right, number 2. A over -6 plus 2 equals 5 is what is given. So then I notice from here to here that the A over 6 stayed the same, but the 5 became a 3. So I used the subtraction property because I subtracted 2 from both sides. And then the next thing here, I would want to multiply both sides by that -6 so that it cancels out so that I get A equals. So this would be the multiplication property. And of course, they're not always just 3 steps, because you know when you're solving algebra, sometimes there's a lot of steps. But there's a reason why you do each step, okay? All right, so first step, take what's given, write it down, tell me it's given. Next step. Well, I'm looking at this and I see that I have -9 times 2, and then I have an 18, and the parentheses are gone. So that would be distribute. So distribute -9. And then here I noticed the 18x stayed the same, but the 27 is gone. So I'm going to subtract 27 from both sides. And then last step, I see that I went from negative 18x to just x. So that meant I divide by negative 18. Okay, so I noticed that I went from the negative 18 to just x. So we're going to divide by negative 18. So what I want you to do now is I want you to come up with your reasons for this one. And I'm going to give you a minute, and then I'm going to write them in, and then I want you to check and see if you got it right. Okay? So in this problem, I look and see that I went from 6x plus 7 equals 8x minus 17 to just having a 7. So that means I subtracted 6x from both sides. Then from step 2 to step 3, I noticed that the 2x is over here by itself, but the 17 is gone. So that means I added 17 to both sides. And then to go from 3 to 4, I noticed that the 24 decreased to a 12. So that means I divided by 2. And then I noticed that to go from 12 equals x to x equals 12, they just switch places, which is that property of symmetric. All right, this one is a little more lengthy, but same thing. Just look at what's happening from each step and tell me, how did you get there? Okay, so I notice I had parentheses. I don't have parentheses, so I'm going to distribute. From here to here, I noticed that there's a negative 7x and a 4x, but it's on the same side of the equal signs. So this is combined like terms. It's not a property we listed, but it is a fact in math. So we're going to combine like terms. And then to go from here to here, I noticed that my negative 3x became a negative 15x because I subtracted the 12x from both sides. And then here I noticed the 14 moved to the other side because it's no longer here. So this would be the addition property because I add 14 to both sides. And then here I would divide by negative 15. All right, here we go. Notice now there are no statements. So now you have to come up with your own statement. There are 4 boxes for each of these, but I'm going to tell you not every one of them is going to use all 4 boxes. Okay? So step 1 is always what is given. So you have to write 3x plus 1 equals negative 14 because it is given to me. I have to start with what is given to me. Step 2, well, what would I do? I would subtract 1 from both sides. So this would be 3x equals negative 15. So I'm going to subtract 1 from both sides. Then if I were just solving this and not having to write reasons, the next thing I would write would be x equals negative 5 because I would divide by 3. And I don't need this last step because I proved what was asked. All right, here we go. Let's look at number 2. So step 1, you always write what's given. So 2 parentheses x minus 9 equals negative 10. And this is given. Step 2, I'm going to write 2x minus 18 equals negative 10 because I need to distribute. Step 3, I'm going to add 18, so that's going to be 2x equals 18 minus 10 is 8. So we are using the addition property to add 18 to both sides. And then this would be x equals 4, which is what they're asking me to prove by the division property. So there are the answers to number 3. Make sure you have them down. Fix them if you wrote them wrong. All right. Number 4. 5y minus 1 over 2 equals 7 because it is given. So first thing I'm going to do is multiply by 2. So I get 5y minus 1 equals 14. Next step, I'm going to add 1 to both sides. So 5y is going to equal 15. And step 4, y is equal to 3 because I divide by 5. All right, so we have several on the back, but I am going to skip down to number 8, and this will be the last one that I do, okay? So step 1, 14 minus 2 times x plus 8 equals 5x minus 3x minus 34, and that is what is given. Step 2, obviously we want to get rid of the parentheses. So 14 minus 2x minus 16 equals 5x minus 3x plus 34, because I need to distribute. Then the next step, I notice as I look on the left side that there's a 14 and a 16. Those are just plain whole numbers, so I need to combine like terms. So 14 minus 16 is negative 2. Then bring down the 2x. Over here, I notice there's x's, so I need to combine like terms. So 5 minus 3 is 2x plus 34. So I combined like terms, or simplified if you want to call it that. All right, now I can start moving stuff around. So I'm going to subtract this 2x from both sides. So I'm going to get negative 2 minus 4x equals 34. So that would be the subtraction property. Subtract 2x. The next step, I'm going to add this 2 over here. So now I've got negative 4x equals 36. So add, well, we don't want to add that. We're just going to add 2. And then the last step would be x equals negative 9 because I divided by negative 4. All right. So the other 3 you can do on your own, or you can just practice.